Hey everyone, today we are going to learn Python operator, but especially for machine learning. So I'm going to keep this simple, no scary math, no complex framework, just clean Python code with real examples, so you can actually understand. By the end of this video, you will know exactly what operators are and why they matter in machine learning, and how to use all the 6 types of operators. So first we will going to through the arithmetic operators. So arithmetic operators you already know, like plus, minus, multiply, divide. But let me show you that the two that matter most in machine learning. So the first one is the double star, the power operator, and okay. So here, so this is the power operator, double star, and these are the plus, minus, multiply, divide. This is the floor division and modulo. So there is an example 3 plus 2 5, 5 minus 2 3, 4 multiplied by 3 12, 10 divided by 4 2.5, but we are do floor division, 10 divided by 3 3, and 10 modulo division by 3, it will return the remainder. And this is the that what I am talking about why this is matter in the machine learning mostly. 2 power operator 3, so it will do 2 to power 3. Okay, so here 2 multiplied by 2 multiplied by 2, right? So here I will show you 2 power 3. So you can see it different at. So why this is matter in the machine learning? How we use in machine learning? Okay. So first, this is simple example that here you can see we are having square 1, square 2, square 3. Okay. And here what I am doing is just simply adding plus square 2 plus 3. This is we are doing addition here, and here we are doing division, this one. And after that we are printing. So you can see here if I print, so we are getting average is 80. But what about the power operator? That's so we have like something called mean square error. If I have here error, so what we have the when we train models, so we measure like how wrong it is. So what we take difference between the actual value. So if we take actual value as a 10 minus predicted value, what model is predicted? So if I take 2, so this will be actual value, or and this is predicted value. So if I do error equals to 10 minus 2, right? So we will get here error. This is error. But what we need to calculate? We need to calculate here mean square error. So what is that? So we just have to do error power operator 2, right? So we will get 64. Or if we have changed, like if I have predicted value 8, if I do this one, it will 4. And actual value is 10, and we are predicting any number, we are getting, like I am getting the value 5. If I do, so the mean square is 25. So this is how we use in the machine learning for the power operator. Next we have the floor division. So how we use this in the machine learning, that is also I will show you. So first you can see we have here 10 floor division by 3, right? It will return 3. So now think I have here total data. I have 100. Right. That is total data batch size. If we do here batches, what we will get? We will get 3. What is that? When we train our model, okay, we don't feed all the data to the model, we convert this into the batches. So we can take any batch size like 30, 64, and we pass in the, so this is how we calculated the batch size, like give the batch size and how many batches we are using. Okay, and we are having 3, but there is still we 10 will be remaining, right? So how we calculate, like how many will be remaining? We can do like remaining data, total data batch size. We will get 10. So this is how we calculate the remaining data. So this is we completed like arithmetic operator. This is easy, plus, minus, multiply, divide. Only mostly we matter power operators with the example I showed you here. And this is floor division, that is example for this one. Here you can see for plus and divide we already saw. Next is power operator, that is like same with that I was showing about. Actual 10 predicted it, so we are doing actual prediction, actual minus predicted, so we'll get error, and error is squared error we are getting 2 here, so we'll be getting mean square error. Okay, so this is for this one. If we run this cell, you'll get the error 2 and squared error is 4. So this is what I am showing here, the best side that I removed the previously. Okay, so this is for arithmetic operators. So next we have comparison operators. So these were true, these cases as a true and false. Let me show you the most important each case in the machine learning cases. Okay, this is an example of the floor division. So comparison operator. So what is the comparison operator? We have double equal. Sorry, we call this equal to, because single equal to is the assignment. Double equal to 5 equal 5, right? So it will return true. If not equals 5 not equals 3, this will also true. If I do 5 not equals 5, it will return false. Here we have greater than 7 greater than 4 true, 3 less than 6, which is less than, greater or equal, 5 greater or equal true, and less than equal to. This is, you can check the comparison operator. So these are the comparison operator we have. Okay, so here we are checking the prediction, like if I x equals to 1 and predicted value equals to 2, we are checking predicted equals to x12, right? We are using equals to operator here. So predicted equal to x12, so if it is 1, it will return correct prediction. If I have predicted value 0.5, right, so we will get wrong prediction, like real value is 1, okay, and model is predicted 0.5. So next we have like probability at 0.75. Okay, So the probability between 0 and 1, if so probability have greater than 0.5, so predicted positive. If it is less than, then it is negative. So here you can see we are using if control flow, and we are having here, and it is greater operator. So you can see over here greater than, right? So this is greater than, we are comparing here 0.5, so it will be positive. So it is matter in the ML. So this is called thresholding. Every classifier does this to turn the probability into final prediction. Yes, no, spam or not spam, and cat or dog. Right? When we predict, like we have cat or dog, and we are working on the classifier spam detector. So this is spam or not. So we decide the which probability we are taking, and after that we compare that probability to the predicted result. So we have to list here actual labels and predicted labels, right? So this is list of numbers. So you can see here. So how we can check accuracy? We are having correct 0, and we are taking AC into, we are getting both the list here actual labels and predicted labels, right? So we have this one actual 1, predicted 1, actual 0, predicted 0, actual 1, predicted 0, right? This is predicted 0, actual 1, and this is actual 1, this is actual predicted also 1. Here actual 0, predicted 1. You can see all the predicted and actual are same only here except this one. So when using this, we are checking if A equals B, like if it will take this one and this one, then it will check equals, it will do correct plus equals to 1. Here you can see we are using plus equals, so we will check this operator also, okay, in the next operator. So here if we run this code, what we will get here? Here we are getting accuracy 0.8. How? Because we are correct. Okay, here we can here. Print. You can see correct is 4 and total is 5. So how we are calculating accuracy? We are checking correct divided by length of actual label. So actual is 5, but predicted is 4. So the accuracy is 0.8, like 80%, and data we are predicted correct. Now next we have logical operators. So in the logical operators we have AND, OR, and NOT. These are combined condition. So how it will work? Like what is the combined condition? We have here true and true. So true and true will be true, always true. If we are having true or operator, and we are using true or false, so it will be actually at least one true. Here we should have both must be true, and we have not. So it will select true or false. So we are giving not true. And the false. Both must be true. It means like if we are using two conditions, that time it will be both. If we are using third, then all the three should be true. We are true to false and false to true. So first we will see the example for AND operator. So if I have age 25 and income is 50,000, say person qualify for loan. So we are checking like if age greater equals to 18. So it is checking if age greater equals to 18. So it should be more than 18-year-old. And we have income greater equals to 30k. If we run this one, so it will be loan approved because if this is 50k, so it will be greater equals to 30. If we give this is 30, that time it will also loan approved, but I have this one is 25, so it will loan rejected because the income is less than. So both the conditions should be true in this case. It should not be 1. If 1 is 2 and 1 is false, it will be failed. Next is OR operator. So we are checking here So has degree and has experience. So has degree false, but he has experience too. So we are checking if has degree or has experience. So any of these it is having, it is hired, and if it is not, then not hired. If I run this one, you can see hired. If he don't have experience and he don't have degree, right? So still not hired because both the condition is false. If I have true and true, it will be hired. So at least that condition we should have. So it should be true for our operator. Not operator, we are having is training false. So if not is training, okay. So what it means? We are checking if the model is training or evaluating. So if we are training, we are using flag. If the training is false, we are checking not, like not operator. Is training, if it is false, then it will come to this one and it will say running model evaluation. If we have true, it means is training, so it will not print anything. You can see here running model evaluation. If I set to true, means it is training, so it will not print anything. Next, we are combining all three. So like I have age 22, score 85, pass 2. So I am checking if age greater equals to 18 and score is greater equals to 7. Okay, and passed. So what will print? Accepted into program. Why? Because age is 18 and score is what is it? Greater than 70 and passed it is 2. Okay, but what I do here, I will use, wait, first I will change here. I will change 2 to false, right? And if I print this one, it will not is printing anything because, or we can use here else print. Okay, if I run this one, so it will get not accepted because we are using AND operator here, and AND operator should be all the conditions should be true because we are having age greater than 18 and score greater equals to 70. We are having 22, 80, both condition is true, but this condition is false, so it's not printing anything. If I change this to the OR, okay, so we are getting accepted into program because we are having OR operator here. So we are getting here, so it will be true these two, but this is false. So still it will be true. The final result will be true. So next we have assignment operators. Okay. So assignment operator store and update values. So the most important one for ML is plus equals. So first you can see this. We have equals. We has assigned 5 to x. We have plus equals, right? So this is the most important to ML. So here, if I use this equals to x equals to x plus 3, right? So it will be do 5 plus 3 8, but we can use this to the like this also, x plus equals to 3. So the operator we are using here, we don't have to use, we just move x plus equals to 3. So similarly we have minus equals to multiply equals to and divide equals. So you can use all these four operator like this. So this is the assignment operators we use. So we have basic assignment here, learning rate, epochs and accuracy. Okay, we are printing this one, so you can see 0.01 and 100. Now this is the most important. So plus equals to, so we accumulate loss during the training. How we will do? We are take the variable total loss and we are using having losses, right? This, right? So we are doing loss in losses. We are iterating through the list and we are doing plus equals to, so it will add and we will try to print like total loss divided by length of losses. So what is the total loss we are getting here? So we will print that also, print total loss right? If I run this one, you will get total loss is 2.599 and the average loss is this one. So we are calculating average loss, total loss divided by number of loss we are having. So we are using that number of loss len and we are passing the losses list. It will return the length of this list losses. So this is how we calculate the average loss and this is how we use plus equals to operate. Okay. When we are updating weights to step by step, here we are using minus equals, this is also same. We are having weight, learning rate and gradient. So when weight minus equals to learning rate multiplied by gradient, so how it is working? We are having updated weight 0.95, right? So what exactly it is doing? It is doing L equals to learning rate multiplied by gradient. Okay. Here print, we are getting L 0.05, right? And weight, what we are having weight here 1.0 and we are subtracting this from this one, weight minus weight equals to minus L. This is what it is doing. But it is first it is multiplying this. So why it matter? Because when we train neural network, so it's update its weights using minus equals. This is called gradient descent. So identify operator. So what is the identity operators we are having? So is and is not, like same object. We check if A is B, like A and B is same object or not. Is not. So not the same object. So if I have a model none and I'm checking if model is none, so what it will print? Like no model is print. So it will print, please train the model first. Why? Because model in the value is none. Model is none. So like we compare like this for none, we use mostly is not double equals to. Okay. So this is how we check. And next is have is not none. So we are checking model, we have random forest. Okay. So we set it model, what model we are using? Random forest. We are checking here like model is not none. So what condition is checking? It is checking model is not none, right? So what it will print? It will print model is ready, making prediction because model have random forest. It is not none. If this model is none, then condition will false, right? Model is none. Condition will false, so it will not print anything because we don't model is not none because we have random forest. So we do is not. So we often check if the model is none before using a model to avoid error. So that's why we use like this model is none. Next we have membership operator. So these check if a value exists inside list, set or string like in. Value is in the collection, not in. Value is not in the collection. Collection what is equal collection. List, set, string these are collection. To check if feature exists. Okay. So I have available feature what we are having age, income, score, and gender. So I will check if income is in feature. If in like income in available in feature. So what it will check? It will check if this income is present here or not. Yes, it is there. Income in available features. We have only age, income, score, and gender. Okay. If I change it to not in. what it will do, it will not print anything because income is present in the available features, but we are checking it is not present or not. Okay. If I change the income to salary, what it will do, it will print feature not found ready to use. So what we are checking salary. Salary is present in this or it is not present, and we are checking that only. So it return the print statement feature found and not ready. So, so this is how we use in and not in operator. So here you can see required age and income credit score and available age and income. We are checking for feature and required. Feature and required what we have this done. So how it will well we are using here nested condition inside for we are using if condition. So first it will iterate element. Okay. So it will first feature what we will get okay. So we will get first age here and we'll check feature age not in. We are checking age not in. So what it is doing, it will check if it is not is there or not available is present in the available, but it is there, so its condition will be false. Same we will go for income. Same when we move to go to the credit score, we will see credit score not in available score. So that is correct because credit score is not present in the available uh, feature. So it will print missing feature credit score. Next we have in that only we are checking. So we have allowed model linear tree and neural networks which use trees. So we checking if chosen model is tree in allowed model. So we allowed what linear tree, yes. So it will do training with tree. And if we set this to the random forest or any other model, so it will return unknown model type. So we think training with tree. Okay. If we use this one, so you can see unknown model type. So this is how we can use this operator. So before running Python, we always check the required features column name and setting is present in and not in. So it make this clean and simple. So quick summary, we completed all the arithmetic operators like plus, minus, multiply, divide, double, power, modulo and floor divide. Next we use comparison operators equal to, not equal to, and greater than, less than, greater than equal to, less than equals to. So this we use for data value. This is for checking predicted and filtering and combining condition. What is that? And or and not. Okay. And plus minus and is not. This is identity and this is assignment. These are the membership. So these are the how much we learned here. All the operators we completed. So if you have any doubt, you can ask in the comment section. Okay. Next, I have the what we are used in the above. So complete example here we have. So step sample data we have age, income, and score. Right. We have assignment here. We are checking minimum age, minimum income, and minimum score. We are combining this income divided by 10 plus score. Okay. So next we having comparison operator. So we are checking age greater or equal to minimum age, right? So it will check true false. So here we have minimum age 18 and we have age 24. So it will true. So this is compared like this. We are income greater or equal to and score also. Step 5 we have logical operator. Age okay, so we are assigning a true false, right? So we are checking age is okay or not. This is okay, so this is true or false. And same for income, we are checking score. If all three are okay, then approved. If any one of this is false, then it will be rejected. Next we have allowed age, into 16. We are creating list here. So what it will return? It will return the age, list of ages. And we are checking age is allowed here or not. Okay, so if I run this one, so what it is saying, approved combined score 123, age is in valid range, and final result is approved, right? So what I am doing here, I am changing age here to 65. Okay, if we go in the end, you can see final result approved, but it is skipped the age is in valid range. This is not approved, executed because the condition is fault. Age is not in allowed range. What we are having allowed range, so we print here, print allowed range. So you can see from 18 to 59. So these are the allowed range. If we, but the age is more is 65. It's greater than the 59. It is not present in the list. So this is how it will check the condition for this one. So this is the complete example. Here we are using all the operators that is we used. So you can check out this, and you can find this note in the GitHub repository. So please like and subscribe and share. If you have any doubt, please ask in the comment section. Thank you.